Have you ever heard someone say, it works on my machine? After working 12 plus years across DevOps, cloud, platform engineering, I heard that n number of times. And almost every time the problem wasn't the application, it was the environment. Docker completely changed how engineers build, ship, and run applications by making environments consistent everywhere. Today, we are not going to install Docker. We are going to build our first real production application, understand exactly what problem Docker solves, and we are going to break it, troubleshoot it, and fix it. And finally, discover where Docker reaches its limits. Because on this channel, we are not learning tools, we are solving production problems. Before we jump in, a short message. This series is part of a very long series where we are building a real production application, cloud native platform while exploring the Kubernetes and CNCF ecosystem from the ground up. If you are building developer tools, Kubernetes platforms, observability solutions, security products, AI infrastructure, cloud platforms, or any CNCF related technology, and you'd like to showcase your product to thousands of DevOps and platform engineers, I'd love to hear from you. You may find my contact details in the video description. Now let's build our first application with Docker. Right now, our platform is extremely small. We have one Linux virtual machine, one application called ShopFlow. ShopFlow has three parts. First is React frontend. Second is FastAPI backend. Third is PostgreSQL. Users can view products. I'm going to show the code in a moment. Place an order, followed by can see recent orders. In the coming months, we are going to grow our application. We are going to add workers. We are going to add scheduled jobs. We are going to add caching, object storage, networking, GitOps, and a lot of other stuff. But none of it belongs to today's episode. Today, the problem is very, very simple. How do we package and run the application consistently? This is our today's problem. Just so you are aware, this is our application. This is our folder structure. ShopFlow episode 3. We have a backend folder, we have frontend folder, we have database, and we have some Docker related stuff. We are going to discuss everything in detail. Now let's try to discuss the production problem. Without containers, Linux server would need Node.js environment. To build, front-end application. It needs Python exact libraries required for the backend. And it also needs Nginx. Then it needs PostgreSQL database as well. Apart from that, it also needs files, permissions, and some startup commands, right? This may work today, but later a runtime upgrade is required. A system package change is required. Another application needs a different version, or a new server is created and one undocumented step is forgotten, right? The problem is not only with installation. The application environment exists as a collection of manual decisions on one single machine. That is our Linux server. We want each component to carry a precise description of the environment it requires. We also want the whole application, this is our goal, to describe as code. That is the problem Docker solves today. If we are going to use Linux server, everything we are going to do manually, and if some version upgrade is done, our application is going to break. That's what we are going to solve using Docker today, right? So I'm going to jump back to my Visual Studio Code now. First things first, if you don't have Docker installed, you have to install that. In this episode, I am using my own computer. I don't have a virtual machine in place right now. So from the next episode, I'm going to set up a virtual machine, most likely on the cloud. But I can explain everything in detail. If you have a virtual machine, my recommendation is do it on the virtual machine. Do not do it on your own computer. First, I'm going to check if I have Docker installed. Yes, I have Docker installed. My Docker version is 29.5.3. Followed by, I'm going to check my Docker Compose version as well. Because we are going to use Docker Compose, I'm going to explain in the later stage of the video. Followed by, we are going to run simple Docker run command to check if everything is working fine or not. I'm going to use Docker run followed by hello world. Unable to find the image locally, it is trying to pull that image and it try to run that. I can see hello from Docker. This message shows your installation appears to be working correctly. I want you to test this properly before proceeding it. Then once we have this in place, now let's go through what exactly we have in our repository. I am going to share each and every file. Every repository is going to be open source. So don't worry about the source code at all. Okay. So we have backend here. We have frontend. We have database. I think I already explained. And we have some other files as well. So let's start with the backend now. First, we have a Docker file in place. As you can see very clearly, for the backend, we have a Docker file. So what exactly we are seeing in this Docker file? The first line shows from Python 3.12-slim, right? We are no longer depending on which version of Python exists on the Linux server. Normally, it used to be like that. We used to install everything on the Linux server or a virtual machine, whatever you can call. But this particular file, if you see clearly, from Python 3.12 slim, this image explicitly contains the runtime expected by our application. Followed by, Docker is trying to install some dependencies. Also, we are trying to copy the application code, and then also we are trying to create some user, we are trying to create some group, then we are trying to expose the port, everything. This particular image is going to carry the environment, the full environment. We are packaging everything in a single image using this particular Docker file. Okay. Now, followed by, we have a front end application. In front end also, we have a Docker file. The same exact steps we are trying to follow here. The front end here using a multi-stage Docker build. For example, from node alpine as builder, followed by working directory, we are trying to copy the package.json file, running npm install. Then we are using from nginx and trying to copy nginx config. This particular file is called multi-stage build. As I said, the first stage is used for Node.js to install dependencies and compile React. The second stage is used to serve Nginx. As I said, we need Nginx as well. If you remember from the previous section, we were discussing about Nginx as well here. The runtime image does not need the Node.js build toolchain. We copy only the output into Nginx. That makes the final runtime smaller. I already explained in detail in my previous Docker series. If you think I'm going a bit fast, my recommendation, please go and check my Docker series. All right. Followed by, we have a Postgres database as well here. And in this, we have init.sql file. For Postgres, we are using an official image, but containers are replaceable and database data is not lost. If you look at here very carefully, we have something called volumes. For mounting a named volume in data directory, instead of directly keeping the data in the container, we are mounting the physical host so that the database container can be removed and recreated while the data is not gone anywhere. We are going to see that hands-on practical. I'm going to show how it actually looks. Today, this solves local persistent problem. It does not yet solve replication, distributed storage, backups, and all of that stuff. Forget about everything. For now, let's focus only on this particular part. Local persistent problem is solved by using volumes. Now, you might have a question, why do we need Docker Compose? Why Docker Compose actually exists? If someone knows the answer, let me know in the comments. Okay. So, why do Docker Compose exist? So, as you see here, we have a backend application, we have a front end application, we have a database. Normally, without Docker Compose, I can run I can say Docker run backend, right? Followed by, I will say Docker run front end, and then I can say Docker run database. So, I can run 3 different containers separately. But I don't want to do that. So for that reason, we have Docker Compose. As you can see, in this Docker Compose file, we are going to define all the services. So services is, let's say, database. For example, I already explained about what we have here in database section. Then we have a backend. So what exactly the backend is doing? We are trying to call the application backend, the application version, the database, the health check, the test command, followed by we are using the front end. Again, the whole source code is sitting here, right? We are just pointing out to those folders and we are adding some more variables. And finally, I can say Docker Compose up space -d space -- build, or I can also say -- build. Anything works. I mean, if I give -build, I can see the logs, what exactly is happening. If I use -d, it is going to be in detached mode. So this is running now. So error, database is uninitialized and super user password is not specified. So we ran into a first problem. For that, I'm going to create a new file called env, and in this file, let's try to define all the details. For example, I'm going to copy this file from here and I'm going to paste it here. I know this is not the right way, but I'm going to keep it like this only. Once again, I'm going to say docker compose up -- build. Now let's see if it can perform the actual stuff. Yes, database is connected and ready to accept connections. So previously this particular file was missing .environment. Now we added this file. This is fine. I am okay with this. So this is how people are running production servers. Now let's try to access the application. So how can we access that? Now let's try to access the application. I'm going to navigate to the browser and say localhost. Here we are. Our application is up and running. And I can clearly see a small application that will evolve into a complete cloud native production platform, ShopFlow. I can see a customer name. I can see some products here, mechanical keyboard, developer backpack, cloud native mug. I can place an order. I have to enter my name. For example, I will write Arbaz and I'm going to place an order. I can see order created here successfully. Recent orders I can see. For the first time in this series, the platform is running a real application. Now let's go back to the Visual Studio Code and I'm going to open another terminal real quick. Now let's try to inspect the system. First, I'm going to start with the Docker containers. Okay. First, we are going to inspect the backend. I can see the container is up and running. We also saw the front end was, let's say, working perfectly fine. Followed by, I'm going to check for the filter front end. I can see the front end also works excellent, up and running. Followed by, we are going to look for the Postgres database, and Postgres database looks perfectly fine. So we can see all the three containers looks excellent. Now let's look at the log files. For example, Docker compose, I will say logs backend, and I can see healthy, everything looks healthy. We try to order something and we are seeing those log files now. Followed by, what we will do now. Now I'm going to say, I'm going to check the health endpoint. So for that, I'm going to say curl http localhost health backend. I get the response saying healthy, status is healthy, service is ShopFlow API, version, hostname, all the details we can see. Followed by, let's look at the backend now. I'm going to use curl once again, localhost ready backend. So status looks ready, database is reachable. Now, after inspecting the system, we can prove that our APIs are working excellent. The readiness also proves that the APIs can reach it database dependency. This distinction matters a lot because a process can be running while it is unable to serve its users correctly. Later, Kubernetes will formalize this using liveness and readiness probes. Now, let's try to break it. I'm going to start with Docker compose stop backend. Press enter. Followed by, we are going to remove that Docker compose rmf backend. Press enter. Container got removed successfully. Now let's try to refresh the application. The front end is still loading, but we cannot see any products. Let's go back to the terminal and let's try to inspect using curl-i HTTP localhost API products. Now I get an error saying 502 bad gateway. I think I explained about this in my networking series, right? Now let's look at the front end logs real quick. Docker compose logs followed by front end. Now if you see here, we see 502 error. Host is unreachable while connecting to upstream because we stopped the container, right? We did it purposely to see what kind of errors we are going to see. Now this is very clear. We are unable to connect to the database. Now let's try to make it up. I'm going to say Docker compose up space backend. Now let's go back to the browser, refresh it. Now we can see the products. We can see very clearly products, and also we can see the recent orders as well. Arbaz created. Now let's jump back. We don't see any kind of errors. Let's try to open another terminal real quick. Now let's try to run curl once again. We get the response saying HTTP 200 OK, and also we can see the details of the keyboard and all of that stuff, right? The application recovered. But notice here, we asked compose to recreate the service. We did it manually, right? We did this manually. It did not come up by itself. We still have one operator managing it. This becomes a very serious limitation later. Now let's jump back to the browser, and here let's create another order. I will say learn with DevOps engineer, and I'm going to place an order. So here, if you can see, I have two orders, right? Now we are going to stop the database. I will say Docker compose stop database. Press enter. Database stopped. Followed by, I will say Docker compose rm space f database. Container got removed successfully. Followed by, I'm going to say Docker compose hyphen up the database. Let's see what exactly will happen now. Now we have two orders created. I'm going to jump back here. Let's refresh it. I cannot see any kind of orders here. Now I'm going to say Docker up hyphen d database. Let's see if our data will come back. Yes, Docker compose up hyphen d database. It started. Let's go back. I'm going to refresh the page once again. We can see the data is back. We can see our data is back successfully because we used volumes. If we did not had volumes, then our data is gone. Now let's try to filter the volume. I'm going to say Docker volume list filter name equal to shop episode 3 Postgres database. So this is the volume which we created. This was part of our docker compose.yaml file. Without this volume, our data would have gone. Now let's understand what exactly Docker changed. Before Docker, our environment could become manual server state. That means runtime versions, libraries, application files, system packages, nginx, all undocumented. I mean, we had some stuff already in place for tracking, but majority of the stuff used to be manual, and we had some configuration tools and stuff in place, but still many people, many projects used to do a lot of stuff manually. So what changed with Docker? So as we have seen, we can describe each environment, right, through a Docker file. We can build a versioned image. We can reproduce the runtime. We can move between machines, which we are going to see in the coming episodes as well. And we can define we can define the complete stack using Docker Compose. Docker gave us repeated builds, consistent environments. Docker gave us isolation, right? It gave us portable images as well. Fast startup, application configuration as code, whatever we have seen in our repository, private networking and local persistent storage, which we created, and also we tried to delete the database, and also we let's say restored the data using the persistent storage. This is why Docker changed application delivery. Now let's talk about what exactly Docker did not solve. ShopFlow works, but everything is still on one virtual machine. The front end, the back end, the database, everything share the same failure domain. If the machine fails, everything fails, right? If memory is exhausted, the services will compete for the same resources. We can run we can run more backend containers manually, but they are still tied to this particular machine. Once we add a second or third server, one compose installation does not manage the whole fleet of the system. Docker solved application packaging and single machine execution. It did not solve fleet wide scheduling, reconciliation, automatic placement, cross machine discovery, or multi machine orchestration. ShopFlow now has its first working release, production platform v0.1. Our front end, back end, and database are packaged as containers. We can reproduce the environment, we can replace it, we can replace containers, and also we can preserve database as we have seen in the video. For one single application on one server, Docker is a huge achievement. But Now imagine ShopFlow become successful. Traffic will increase for sure. We need 5 backend instances. We are going to add a second server followed by a third server very soon. Who decides which machine run each container? Who notices when a machine disappears? Who keeps the required number of instances running? Who will send traffic to healthy instances? Only healthy instances. Who is going to coordinate across the fleet of machines? Docker solved how we package and run the application. It did not solve how we operate an entire fleet of machines. In the next episode, we are going to grow our ShopFlow application beyond one machine and experience why Docker stops being enough. Thank you for watching. I'll see you in the next episode.